Hi everybody, today I want to show some of my shaders. It's work in progress, but still I have something to show you. So I have three materials for player stones, three materials for multicolored stone, and one material for stones that are presented on the map. Besides that, I've made simplified reflections. So I'm gonna talk about that kind of stuff today. Let's go. So the first material is player cloth material. Um, it's simple Lambert lighting plus normal map plus artificial ambient occlusion from normal map and plus rim lighting. All player materials have rim lighting parameter because I have to be able to highlight them on the field. So in highlighted mode, it's looking like that. The second material is player specular. It's used for spherical stones. So it's Lambert shading plus specular map plus rim lighting plus fake translucency, which is just adding some color to all the surface of the material. The third player material is player stone. It's Lambert plus normal mapping plus fake. Oh no, here there is no ambient occlusion from normal mapping, and I will explain why. So it's also rim lighting and specular map. So if we look closely to this material, or maybe change color to something darker, then we'll see that it has specular map. We can change light direction just to ensure that this is specular, it's not simple glowing. The next material is Lambert plus ambient occlusion. It's real ambient occlusion plus occlusion from normal mapping. And last three materials for today are presented here in multicolored stone. So it consists of three different materials. One for the border, it's ambient occlusion. No, it's normal map plus ambient occlusion from normal map, and different color for rim lighting because this stone belongs to both players, so it has to be highlighted differently, and the color of rim lighting changes with time from one player to another player's color. The second material is inner triangles. They are just Lambert lighting plus specularity plus color changing mask and glowing mask. So if we can see on this blue side there are some strokes of light blue. It's glowing mask. And the third material is this inner glowing, which is just animated transparency. The color of this glowing changes through the game. So when it's first player's turn, then the color of this glowing is the same as the first player's color. When turn changes, then color changes to the other player's color. So right now we are not in game mode, so it's white. So that's it for the demonstration of shaders, and now I'll explain how they all made. So if you are not interested in technical stuff and implementation details, then you can just turn off this video. So let's start from the cloth player shader for this cubic stone. And the first question is adding a normal mapping to your shader. It's relatively good described in the article on Wikibooks. But the only exception is if you want to use Unity normal map compression, you have to use built-in Unity function unpackNormal, which is available after you include UnityCG file. Then you can use this function to get a decoded normal map from the texture which is compressed with Unity normal map compression. If you don't want to use this compression, or if you use alpha channel to store some else information or other maps, then you have to use the method which is described here in the article. It's just a linear function on X and Y components of the color which we get from the texture. The other step you have to do is you have to add a UV mapping for your model. I've made a simple UV map that allows Blender to generate tangent space when exporting FBX object. So Unity can load these tangent vectors, not recalculate them from UV map, and use them to pass to your shader through the tangent semantics word. So that's all for normal map. The other interesting detail that I've added, it's not very noticeable here on cloth, but on other normal mapped objects it's pretty noticeable, and it's fake ambient occlusion from normal map. I'm evaluating normal map.z value, and if it's not equals to 1, then I reduce factor for ambient occlusion color. It's noticeable on objects where normal map is not so intense as here, for example on stones, but here it's used too. And the other small detail that I forgot to mention is that normal map is pretty small for this object. It's only 128 squared, so it's tiled to cover the entire object multiple times, 6 times here. So you don't have to use huge normal map textures. The only thing you have to do is to make this texture tileable. I generated almost all textures that I use in GIMP 2, and it has a built-in function to make texture tileable. And after you search web a little bit, you can find the script that allows to generate normal map from any texture in GIMP 2. So after making texture tileable, you can generate a normal map from it, and it will be pretty seamless on the model. And rim color there is nothing special in it. It's just based on dot product of view direction and normal direction, so it's not a rocket science. Let's move on to the sphere specular material. It doesn't use normal mapping, but it has a specular map from small tileable texture with only one channel. Actually, it's RGB, but it's compressed as it has only one channel. So as with the cube, I've made a UV mapping for this object, but now I don't use tangent space, so I turned off this option in FBX import settings in Unity, because tangent vectors are also take space in memory. So if you don't use normal mapping on some models, then turn off this option. The other optimization that I used on this sphere is calculating reflection vector and specular intensity in vertex shader. We can do that because our model doesn't have smooth normals anywhere, so it's like low poly style, and for every triangle the specular value is almost the same through the entire triangle. So we can calculate it once only for vertices and then use pre-calculated value of specular intensity in fragment shader. It will be much more optimized than calculating specularity inside fragment shader. If you have large triangles on your model, then this tip is not for you, because specular intensity will change from one point to the other point, but the changes are not so fast as in my case, so I can use this hack. Maybe you can do it for some of your models too. The next material is player stone material. It uses normal mapping and specular map. So the model for this stone is simple cube with a lot of faces and smooth and normals, and UV map is simple. Every large face have the same UV mapping. So Unity set up to import tangent vectors for this model in order to calculate tangent space matrix here in the shader to apply a normal map to the model. And here I calculate specularity in fragment shader because firstly our normal direction depends on the computations from normal mapping, and we don't have the results in vertex shader. So if we want to make a specularity that is that's not applicable for the normal mapped model but for simple shaded model, then we can make it in the vertex shader, but for my purposes it not looks good with such kind of normal map. So I calculate normal here in fragment shader, and then I calculate rim lighting and specular intensity, and then I apply alpha channel of my texture to the specularity. I made a texture which is here. I have RGB channels for normal map for this player stone, and alpha channel stores specularity map. Because I have all 4 channels, I can't apply Unity normal map compression for this texture, and I use not unpack normal function, but the simple formula from the article about normal mapping in Unity. That's how I use RGB channels of my mask to normal mapping and alpha channel for specular mapping. Now let's look at the material that is used on stones and columns. It's Lambert shading with normal map and ambient occlusion. So right now it uses 2 textures. One of them is small normal map that is tiled, and the idea is the same as for the cloth cube. We have a model with a UV mapping for normal map, and we export tangent space for that UV map. Unity imports it, and we calculate tangent, b-normals, normals and use them in fragment shader to apply normal map to our model with tiled texture. But the interesting part is applying ambient occlusion to our model. This model has 2 different UV maps. First is used to normal mapping, and it's used to generate tangent space. It's very important that tangent space will be generated based on this UV map, not the other, which is used for ambient occlusion. So the second UV map I've made, it's well, it's pretty unusual because I took all the faces that not occluded by anything else, and they will produce just white color on the ambient texture. So I made them all in one small patch on this UV map, and other objects which do have some shading based on ambient occlusion, they have more space on this texture to be rendered. By the way, I rendered this light map in Blender. There are different tutorials on the web on how to do that, and I'm pretty happy with the result. I exported this texture as of course as JPEG, but for ambient occlusion we have to use only one channel because it's shaded or lighted. It's not full RGB space unless we're using some strange colors of light source. But in my case, I use completely white source of light, so I decided to incorporate different ambient occlusion maps into one texture, and here we can see a texture. It's only 128 squared, and this quality is enough for this column. So the column seems like it uses red channel of this texture to apply it as an ambient occlusion texture, and this stone uses green channel as an ambient occlusion texture. So my material uses two textures. One of them is tiled and small, the other one is not tiled and uses other UV mapping. If you want to use different UV maps in your shader, then you just enumerate them with 0 and 1. So one interesting moment about shading of this column is the fact that I haven't baked ambient occlusion for normal mapped model. I just made ambient occlusion for regular model, but here we can see that normal map affects shading, especially in the shadows. I've added this effect simply by adding this factor to my ambient occlusion factor. So if normal map contains some information and our normal is not directed straight perpendicular to our surface, then we have to decrease light that can be perceived as an ambient occlusion light. So after adding this factor, the areas within shadows look more realistic, and you can compare it with absence of this shading. Is just raw, it's just gray. You can see ambient occlusion from texture, but you can't see any effect of normal map, and it looks strange. So this factor helps. You can change this number however you want. The more it is, the more effect will be from normal map on the ambient occlusion shadows lighting. So that's it for the stone material. Now let's look on the multicolored stone. So the first material is border material. It's pretty simple. It's just normal mapped with some texture and rim color that is changing its color throughout the time. If we look in the shader, the most interesting thing is rim lighting that is later calculated from lerp and player colors with player factor, and the player factor is changing through time. So if you are using some functions like sine or cosine from time, then you are doing a lot of unnecessary work in your shader, because Unity already provides such vectors as scene time, cos time, and time, and they contain already computed sine and cosine values for time. You can use them. So this material is pretty simple. I will continue to the next one. That is inner triangle of this stone, which changes its color throughout the time. So this material has interesting texture to be able to change colors on its sides with different phase and through this effect. Let's look at the model. The mesh itself, oh, it's not the mesh that I wanted. The mesh itself has this kind of UV map. It's exported without tension space because we don't need it here. We do not use any normal mapping in this material. And that's the texture that stores different information in different channels. So we have a green channel, which is used to add artificial glowing in these stripes on the material. It's not very interesting. Then we have blue and red channel. Blue channel is used to change the phase of these faces when they are changing its colors. And the red channel is used to add some variability to this phase. So if we look at this blue channel, then we see that one face has nothing in it, the other one have a quarter of blue value, the third one have 1/2 of blue value, and the last one has 75% of blue value. And that ensures that major phase shift is the same between these triangles. The red channel adds small changes to the phase. So in the shader it looks like this. Here we are sampling our texture, and later we use green mask to modify our lighting, and red mask and blue channel to use it as a phase for our function of player factor. So player factor is used to lerp between different player colors, 1 and 2. So it has to be changed from 0 to 1 and from 1 to 0. I use step function and fraction function. It's more effective than sine or cosine because it's just taking fraction of a number. And I use blue mask as a major phase shift, and red mask is multiplied by a small number to add small changes to the phase. Because we want it to be very subtle and slow change, so it has to change slowly, because if we drop that factor, then the whole triangle will be changed in just one moment. We do have some variability because of compression and sampling. So that's how I use my texture for this model. Okay, let's go to the glowing inside this stone. It's made with just a couple of quads, and the UV map is simple. The whole triangle inside is mapping on the on these pixels close to the bottom border of the texture, and I use this glowing mask. It's also a small texture with different information in different channels. I use at least 2 of those channels, red and blue, to mix them together. So I sample this texture in different pixels across one horizontal line. If we are rendering, for example, fragment in the middle of this glowing, then we would sample two different pixels, and the distance from those pixels is defined by the time that is passed from the beginning. So here in the shader, I use this displacement that is just simple time dot y and 0. So I add it to my UV position and subtract, and make two different samples and use them, and use their multiplication as my alpha channel for the output color. So that is so simple. The main problem is to compose such a texture, and I've also made it in GIMP 2, and I found a free script that allows you to make a texture tileable across only one axis, and I used it to make it seamlessly repeated across horizontal line, so you don't see any seams here on the glowing texture. So that's it for multicolor materials. The last feature I want to show is simplified reflections. In my game, as you know, there is a water surface which has some kind of reflections in it, and most of the time they are distorted, so you can't really see any details in it, because every time the water surface is curvy, and so we don't need extra details here. And these reflections, there is only one reflection. That reflection renders from other camera, which is situated underwater and looks upwards on my scene. So Unity has such a feature like shader replacement, and we can replace all shaders from the objects that we are about to render to some other shaders. So here we can see that, for example, the sharp stone does have normal maps on it, but in reflection they are not rendered. The same is for other stones. There is no specular map here, there is no transparency here, it's just alpha cut off, and there is no normal maps or ambient occlusion for reflections of columns and stones. And this approach reduces time that needed for my reflection to render. So I think it's helpful, but the downside is that I have to rewrite all my shaders that I used for my materials inside one huge shader. And shader replacement feature works like this. So it looks at the shader that it has to render, and when I called shader replacement, I specified that I want to change all shaders that contains tag reflection type. So before rendering an object, Unity looks at the tag that is here. Reflection type here is multicolor inner, and I provide one shader that has to contain all replacement shaders. So it's a huge file, and it contains different subshaders with different reflection type that I specified. So for example, if we want to render multicolor inner shader, then shader replacement feature will find this subshader and use it instead of original multicolor inner shader. So I didn't found a way to make it more I don't know, gracefully. If you know how to make how to avoid such a huge files with shaders and use shader replacement, then write it in comments, because I don't like that all my different shaders that are not related to each other, they all have to be duplicated here, and it's not very good for a programmer to keep different entities in one file or one class. So I think that's all for today. It's a pretty long video, but I hope it was helpful. If you have any suggestions or thoughts how to improve something here, please write it in comments. Goodbye.